The word robot evokes images of futuristic machines. But the concept of robots is not new. Early examples like mechanical automatons can be traced back centuries. These devices, often clockwork creations, were marvels of engineering. They could perform specific tasks, like writing or playing music. However, they lacked a key element: programmability. The real turning point arrived with the advent of computers. Computers offered a way to program machines with instructions. This advancement paved the way for the first industrial robots in the mid-20th century. These robots, like the Unimate used by General Motors in 1961, could perform repetitive tasks on assembly lines. This marked a shift from purely mechanical automation to programmable robots. These early robots were groundbreaking, but their programming was complex. It required specialized knowledge. This limited their use and slowed down their adoption. However, the seeds of a robotic revolution had been sown. The coming decades would witness rapid advancements in both robotics and computer science. These advancements would change the world as we know it. The evolution of robots is intricately linked with software development. Early robots were limited by their programming. They could only perform pre-programmed tasks. But with the advancement of software, robots became more versatile. They could adapt to different situations. Programming languages specifically designed for robots emerged. Languages like Pascal, C++, and Python allowed for more complex instructions. Robots could now process information from sensors. This enabled them to react to their surroundings. They were no longer limited to predefined paths and actions. The advent of artificial intelligence marked another significant leap. AI algorithms enabled robots to learn from data. They could improve their performance over time. Machine learning, a subset of AI, became instrumental in developing intelligent robots. These robots could make decisions based on patterns and data. They could adapt to new situations without explicit programming for each scenario. This fusion of robotics and software led to the development of robots that could perform increasingly complex tasks. They could navigate complex environments, recognize objects, and even interact with humans in a more natural way. This opened up a world of possibilities in various sectors, from healthcare and manufacturing to our homes and daily lives. Programming robots was once a domain reserved for highly trained engineers, but the landscape is changing. Modern robot programming emphasizes user-friendliness and accessibility. This shift is fueled by intuitive interfaces and AI-powered tools. Visual programming interfaces are replacing lines of code with graphical elements. Users can program robots by dragging and dropping blocks, representing specific actions or instructions. This approach simplifies the programming process. It makes robotics accessible to a wider audience. Even individuals without extensive coding experience can program robots for basic tasks. AI is also playing a transformative role in robot programming. Machine learning algorithms can analyze demonstrations and generate robot code automatically. This means that robots can learn by watching humans perform tasks. They can then replicate those actions. This learning by demonstration approach removes the need for manual programming for every single step. These advancements in robot programming are democratizing access to robotics. They empower individuals and businesses to harness the power of automation. This has profound implications for various sectors. It's paving the way for a future where robots are no longer confined to factories and research labs, but are integrated into our everyday lives. The healthcare industry is undergoing a robotic revolution. Robots are no longer confined to science fiction. They are actively transforming various aspects of healthcare, from complex surgeries to everyday care. Robotic surgery is now relatively commonplace. Surgeons use robotic systems to perform minimally invasive procedures with enhanced precision. These systems provide surgeons with magnified three-dimensional vision and greater dexterity. This allows for smaller incisions, reduced blood loss, and faster recovery times for patients. Robots are also playing a crucial role in therapy and rehabilitation. For patients who have suffered strokes or spinal cord injuries, robotic exoskeletons can assist with mobility and help retrain muscles. These devices provide support and feedback. This allows patients to regain lost function and improve their quality of life. In elderly care, robots are being used to provide companionship and assistance with daily tasks. These robots can remind patients to take medication, monitor vital signs, and even provide social interaction. While they can't replace human interaction entirely, They can offer valuable support and improve the quality of life for seniors who wish to remain independent. Section 5. Robots on the factory floor, boosting efficiency and enabling new possibilities. Robots have been a fixture in factories for decades, but recent advancements in robot programming are taking automation to new heights. Robots are becoming smarter, more adaptable, and capable of collaborating with humans more effectively. Traditional industrial robots were typically large, stationary machines. They were designed for specific tasks like welding or painting. Modern robots are more versatile. Collaborative robots, or cobots, are designed to work alongside humans. They are equipped with sensors to prevent accidents. This makes them safe for close proximity work. AI-powered robots are transforming manufacturing processes. They can analyze data from various sources. This includes production lines and customer demand. This allows them to optimize production schedules, identify potential bottlenecks, and even predict maintenance needs. This results in increased efficiency, reduced downtime, and improved product quality. The rise of three-dimensional printing is also intertwined with robotics. Robots equipped with three-dimensional printing capabilities can create complex parts and prototypes with incredible precision. This technology is enabling manufacturers to produce customized products on demand. It reduces waste and opens up new possibilities for design and innovation. Section 6. Robots in our homes, automating chores and companionship. Robots are no longer confined to factories and hospitals. They are making their way into our homes. From robotic vacuum cleaners to smart home assistants, robots are becoming increasingly integrated into our daily lives. Robotic vacuum cleaners and lawnmowers are now commonplace. They automate mundane chores. This gives us more time for other pursuits. Smart home assistants like Amazon's Alexa or Google Home are becoming increasingly sophisticated. They can control our appliances, play music, provide information, and even order groceries with voice commands. Social robots are also emerging as companions and assistants. These robots are designed to interact with humans on a more personal level. They can recognize faces, understand emotions, and engage in conversations. While still in their early stages, social robots hold potential for providing companionship, assistance with daily tasks, and even educational support. As robot programming becomes more intuitive and robots become more adept at understanding and responding to human needs, we can expect to see even greater integration of robots into our homes. The future might hold personalized robot assistants that cater to our individual preferences and enhance our quality of life. Section 7. The double-edged sword. Examining the potential risks and ethical dilemmas. The advancements in robot programming and the increasing integration of robots into various aspects of our lives come with potential risks and ethical dilemmas. As with any transformative technology, it's crucial to approach these advancements with careful consideration and proactive measures. One of the primary concerns is the potential impact on employment. As robots become more sophisticated and capable of performing tasks traditionally done by humans, there is a risk of job displacement. This is particularly relevant in sectors like manufacturing, transportation, and even some areas of white-collar work. Another concern is the ethical implications of using robots in certain contexts. For example, the use of autonomous weapons systems raises significant ethical questions about accountability and the potential for unintended consequences. Similarly, the increasing use of robots in elderly care necessitates careful consideration of the ethical implications of replacing human interaction and care with machines. Privacy is another crucial concern. As robots become more integrated into our lives and collect data about our behaviors and preferences, ensuring data privacy and security becomes paramount. Clear guidelines and regulations are essential to prevent misuse of personal information and ensure ethical data handling practices. Section 8. Navigating the future: education, regulation, and responsible development. The future of robotics is filled with both promise and uncertainty. To harness the transformative potential of robots while mitigating potential risks, a multi-pronged approach is necessary. This includes education, regulation, and responsible development. Education is crucial to prepare the workforce for a future where robots are commonplace. Fostering STEM education, science, technology, engineering, and mathematics, from a young age is essential. This will equip future generations with the skills needed to design, program, and work alongside robots. Regulation plays a vital role in ensuring the safe and ethical development and deployment of robots. Establishing clear guidelines for robot behavior, data privacy, and accountability is crucial. International collaboration is essential to develop universal standards and prevent a patchwork of conflicting regulations. Responsible development involves prioritizing human well-being and ethical considerations throughout the entire life cycle of robot development. This includes involving ethicists, social scientists, and the public in the design and deployment of robots. It also means considering the societal impact of robotic advancements and taking steps to mitigate potential negative consequences. Section 9. A world transformed. Embracing the potential of robotics for a brighter future. The future of robot programming is bright. As robots become more intelligent, adaptable, and accessible, they have the potential to revolutionize countless aspects of our lives. From healthcare and manufacturing to our homes and daily routines, robots hold the key to solving some of the world's most pressing challenges. Imagine a world where robots assist surgeons in performing complex life-saving procedures with unparalleled precision. Envision factories where robots and humans work side by side, boosting efficiency and productivity while creating new job opportunities. Picture a future where robots help us care for our elderly, providing companionship and assistance while allowing seniors to maintain their independence. The realization of this optimistic vision requires a concerted effort from scientists, engineers, policymakers, and the public. By embracing responsible development, fostering education, and engaging in thoughtful discussions about the ethical implications of robotics, we can harness the power of this transformative technology to build a brighter future for all. The future is not something that happens to us, it's something we create. Let's work together to ensure that the future of robotics is one that benefits all of humanity.